Hello everyone and welcome. The Singleton pattern is a powerful tool for controlling the creation of objects and ensuring that a class has only one instance throughout the entire application. But in the last tutorial video on Singleton design pattern, we saw how the naive implementation fails for a multi-threaded application. And we also learned how we were able to fix the issue by using something known as DCL or double checked locking. If you haven't watched our last video on Singleton pattern or would like to learn more about it, I highly recommend you to watch that video first, in which we discuss about lazy initialization, thread safe singleton and more. I have linked that one on the screen right now and would also be adding a link in the description. Alright, so coming back, we know that to make Singleton work for multi-threaded applications, we need to use DCL. In this video, we'll be discussing DCL in much more detail and see how it is implemented the way it is and how it helps prevent possible issues in a multi-threaded application. DCL is a very frequent question in design interviews and honestly, it's not that difficult to understand. In this video, we'll try to reach the most efficient solution step by step, discussing issues in one step and fixing them to move on to the next one. By the end of the video, I can ensure you that you'll have complete understanding of this concept and will be able to answer all the questions that might come up regarding this. So let's get started. Alright, so as we know that our naive implementation containing a single null check breaks for multi-threaded application. Let's try to see and understand what the issue is when multiple threads interact with our naive implementation of Singleton. We'll be using the same setup we used in our Singleton video or this video as well. We have two runnables, each trying to get an instance of the Singleton class, and in the main thread, we start the two threads one after the other. Suppose multiple threads are trying to get an instance of our Singleton class at the same time. First thread starts executing our static getInstance method. If it is not the first call to this method and the instance is not null, then there are no issues. We just return the static reference and all is good. But issue comes when this is the first call to the static creation method and the instance is null. Suppose first thread comes and sees that the instance is null. So it tries to create a new instance and goes to the constructor. But while the instance is being created, suppose another thread comes. If the first thread is still in the process of creating the instance, the static instance is still null. Then even the second thread will go and create a new instance. So because of this, multiple instances got created of our Singleton class. Let's run and see what happens. Alright, so we are able to see that the reference of the class in both threads is different and the value is different as well. So now how to fix this? Well, the issue is that multiple threads are trying to create instance at the same time. So to fix this, we only need to prevent multiple threads, right? So how can we do that? We definitely can't control the application to not call our static creation method at the same time for multiple threads. We have control over only our method. So to prevent this issue, we need to stop other threads from trying to create an instance if a thread is already creating it. Now, how can we stop threads from executing a piece of code if another thread is already executing it? This can be achieved by using a synchronizing block. The code inside a synchronized block can be executed by only a single thread at a time. Other threads have to wait while the first thread is executing it. Another thread can start execution only after the previous execution has completed. So let's try and add this synchronization design to our static creation method. We can wrap our entire function logic in a synchronized block. Now let's try running this and see if it works. Okay. Now the reference of the object in the two threads is same and the value is same too. So wrapping the entire logic in a synchronized block works. But is this an efficient solution? Let's see. This synchronized block, as we know, now blocks threads and allows only one thread at a time to execute the logic inside. We added this block because before this we were facing an issue when two or more threads were trying to create an instance at the same time. Note that issue was present only initially when the Singleton instance was null. Later there was no issue. But here, with this synchronized block, being the outermost block in our code, it will block threads all the time. Even when the instance is not null and we didn't had any issues, the blocking effect of synchronized block is still present, and all threads have to potentially wait for some time to get the static instance, and it can cause some unnecessary overheads. How can we fix this? Well, we want to have the synchronized behavior only initially, right? When the instance is null. So why don't we move the synchronize inside the null check? That way it will be executed and block threads only initially when the instance is null. But once the instance is set, my synchronized block will not be in picture anymore. So let's try this. Let's move the synchronized block inside the if condition. And then we can move the object creation code inside the synchronized block. Okay, done. Let's run this and see what happens. Okay, this messed something up. References printed in the output are both different and also the values are different. Okay, so still something is wrong, and let's try and figure out what it is. If you look closely, this is very similar to what we had in the naive implementation without synchronized. Here also, if we suppose that we have two threads trying to create an instance at the same time, they both will find the instance null initially and will enter the if block. Now the synchronized block will let one thread, suppose thread 1, to go inside, but will block thread 2. So our thread 1 is inside and the thread 2 is waiting outside. Now inside the synchronized block, thread 1 creates an instance, and once it is completed, it exits the synchronized block and returns. Now after thread 1 has exited the synchronized block, thread 2 enters the synchronized block and runs the code. The code here is to create an instance, and that is what it does. So it creates yet another instance, and this is how we end up with multiple instances. How to fix this? Let's identify the issue here. We had the null check once outside. If two threads come at the same time in the beginning when the instance is null, both will pass this null check and go inside. Now inside, synchronized block will allow only one thread to go inside at a time. So thread 1 goes inside and executes the line to create a new instance. Only when it exits the synchronized block, thread 2 is able to enter. Now even thread 2 is able to create a new instance, even though the static instance is not null anymore and has been set up already by thread 1. We need to fix this particular thing which is causing the issue. How to fix this? We can fix this simply by adding another null check inside the synchronized block. Let's see how this will help. Consider from the starting that my two threads are trying to create an instance. They enter the function and see that the static instance is null, and both enter the if block. Now, synchronized block allows thread 1 to go inside and blocks thread 2. Now, thread 1 goes inside and sees another null check. Is the instance null? Yes. So, thread 1 goes inside. Then inside it creates a new instance and assigns it to the static field. Post that, thread 1 exits the synchronized block. Now, my thread 2 enters the synchronized block. Inside, it sees a null condition. Is my instance null now? No, not anymore, as it has already been set by thread 1 just before thread 2 was able to enter. So this null check fails, and in the end it returns the existing instance. So only a single instance is created now, and hopefully this solution should work. Let's run the code and check out. Nice! As we see, the references are same and also the values printed are same. This solution works and is efficient as well. Now some of you might be wondering that how is this efficient when we have added duplicate null condition? But the point to note here is that this second null condition will be executed only in the beginning when the instance is null. Once it is set, control flow won't even come inside the first if block. So this duplicate if condition will not have any effect. Now This is the final solution. No more optimizations to do here. And yeah, if I didn't mention, this is DCL, double checked locking. Double checked because we use two null checks and the one synchronized block for locking. One check outside the synchronized block and another one inside. So you see, terms like DCL may seem very complex in the beginning, but once you understand how it works and why it works that way, things become very simple. I hope with this video I was able to clear out all your doubts about DCL today and you have learned something new. If yes, then I'm sure that you have much better understanding of the Singleton pattern and will also be able to answer any interview questions that might come upon this. Do let me know in the comments how you like the video. Also, please do like and subscribe and share this with your friends if you like the content. Thanks for watching.